Our today's challenge is to design a chat system like WhatsApp. Now, before we start building our architecture, we need to go through the design specifications that we have. Let's go through these one by one. So first of all, we have the functional requirement, which is basically real-time one-on-one group messaging, then delivery receipts. Then we have the non-functional requirement of less than 100 millisecond message delivery, 2 billion users, offline storage fallback, etc. Then we have the constraints, which are end-to-end encryption, sticky WebSocket session, etc. Then we have budget, which is $19.5 per hour limit. So we must have a budget limit as well. And here we are considering $19.5 per hour. And capacity. For capacity, let's say we have 2 billion users and 65 billion messages per day. And if each message considers or consumes 100 bytes of memory, then approximately for 2 billion users and 65 billion messages, we would need 6.5 terabytes of memory per day. And we have 100 million concurrent WebSocket connections. Now, the key trade-off in our architecture that we need to consider is online delivery versus offline queue, which is basically WebSocket push versus pull on reconnect. So the trade-off is real-time versus reliability. Now, as we will keep on building our architecture in our canvas, we will see each of these mission requirements that we have right here getting checked. So let's start building our architecture. The first and foremost thing that we need in our architecture is a client. Basically, all the requests originate from a client and go to the server side. Now, in our server side, the first point of contact for the request will be a load balancer. So the request comes from client to the load balancer. Now, a load balancer, as we can see right here, it distributes the incoming traffic across multiple servers. So no single server gets overwhelmed. It detects unhealthy servers via health checks and stops routing to them. So basically, a load balancer is a server itself, which is responsible for managing the load coming from the client side and distributing them across various servers that we have in our architecture. For simplicity, here we will be considering two servers for in our architecture, and the load balancer will be connected to each of them so that it can route the load to each of these servers. So it basically distributes the load between our servers that we have so that one server does not get overwhelmed. Now, since it is a chat system, so we must have real-time connection. For having real-time connection, we have something known as a WebSocket connection between the chat server and the client, which basically gives us a real-time connection between the client and the server. And with the help of WebSockets, we have real-time communication between the client and server. Like in normal client-server architecture, what happens is the client sends a request to the server and the server responds back and the connection is closed there and then. But in a WebSocket connection, what happens is the connection persists and we can have real-time communication between the client and server. So since it is a chat application, we need this real-time connection. Now, since we have messages and various other things that we need in our application, these need to be stored somewhere, right? So for storage, we are having a particular storage right here and each server needs to be connected to the storage. And we will also have something known as a cache memory. Now, a cache memory is a type of memory which helps us to retrieve data in a much faster manner as compared to retrieving data from a normal or main database. Because in cache memory, basically we store data in the form of key value pair. So data retrieval becomes very fast here. So the hot data, which is frequently requested from the client side, or the temporary data, etc., can be stored in our cache memory. So we also need cache memory. For example, like session storages are temporary data, like sessions are temporary, right? So the user sessions, etc., these kind of data can be stored in our cache memory that we have. So we have our normal storage and our cache memory right here. And we can see that these requirements are getting met one by one. Now, after all this, we need to perform or we need to have various services in our backend as well, right? For example, if we receive a message in our server and we need to notify the other user that the user has received a message. So for that purpose, we need a notification service and we have multiple services other than that as well, which need to be performed or handled in our backend. So if every service is performed synchronously or every service is met there and then, this will take a lot of time and this will make our application very slow. So we can store all the tasks that we need to perform in a particular structure, and these tasks can then be processed in the background one by one whenever the services responsible for addressing these tasks are available. For that purpose, we have something known as a message queue or a message router. So whatever tasks we need to perform are stored in this message router. And from the message router, we will have it push these tasks to various services, or various services can pull these tasks which are stored in the message queue. So we can have a pull or push architecture. It depends on us. So let's say if we are considering the push one, then the message queue will push the various tasks that it has to various services or various workers which are connected to it. So let us consider a basic service, like for example, the notification service. So if we need to notify the user, this task will come onto the message queue, and then from the message queue, it will go to the push service, or it will be pushed to the push service. And from the push service, basically, we will notify our client directly. So this is the basic functional architecture of a chat application. And other than that, we also need to have a monitoring and alert system. This is because, like here we can see our architecture is pretty simple, but it is a functional architecture, but it is a simple one. In complex or bigger architectures, there are multiple servers, various load balancers, number of services. All of these need to be monitored because if anything goes down, then the developer needs to be informed about it so that it can be brought up immediately. So we need to monitor each of the important services that we have in our architecture, and for that purpose, we have monitoring and alert system, and every important component should be connected to the monitoring and alert system so that we get monitored whenever something goes down. After all this is done, this is the basic architecture that we have for our simple chat application. And after we are done, we can see that all the mission requirements have been checked. Now, one very important point which we need to keep in mind is that this architecture right here is a very simple blueprint, but a complete blueprint of how a chat system works. We can complicate our architecture even more by adding a lot more chat servers, by increasing the number of servers in our architecture, by increasing or by putting different types of database for different data storage or different types of data storage. We can add multiple services to our message queue so that there are numerous services in our backend, and we can scale up or optimize our architecture even more. But the thing is, here we have a budget constraint, right? We have a budget constraint of $19.5 per hour. So if we complicate our architecture or if we add more elements, it will exceed our budget limit. So keeping this budget constraint in mind, this is the practical or optimal architecture that we have. If we have a budget limit of more than $19.5 per hour, or like let's say we have a lot more budget limit than this, then we can like complicate our architecture even more, like increase the number of horizontally scale up our architecture by increasing the number of servers, add more services, and can make our and we can optimize our architecture even more. But here, since we have a particular budget constraint, according to this budget constraint, this is the optimal architecture that we have obtained, and we can basically run our architecture after that, and we can see that our architecture got approved. So once our architecture gets approved, we can move on to the next level. We can also see here that all our requirements got met, and we have all these stats right here for the architecture that we have designed. And this was the design of a chat system like WhatsApp.